What up, fam? How we doing? Welcome to this parent function round 2. Let's get the show on the road into this stuff. So, important idea here. Remember to read the instructions, not doing all the different things, because we did so many different things in this guy. We got to make sure we're doing the right ones. So it says describe the transformations. So anytime it says describe the transformations, we're expecting those English words to be popping out of here. So what words are we looking for? Well, in this case, the original is pointing off to the right. The new one is pointing off to the left. We call that a reflection over the y-axis. And so it's pointing that way, now it's pointing that way, and it's also moved down 1 unit. So we call that a translation or a shift down 1 unit. Translation down 1. And that's the whole question. That easy. Move on to number 2. So number 2, same exact concept. We are having a reflection over the x-axis because we're pointing down this time, and we have shifted right. And how far have we shifted right? Looks like we shifted right exactly 1 unit. Cool beans. Let's do, keep it moving. So now it says write g of x in terms of f of x, a solid line. So a lot of students were struggling with this in class. You got to remember that basically what this means is it wants an answer in this form. It wants an answer in this a times f of b times x minus c or plus c plus d form. So it wants that format. And you're going to take that format and work with it to create the answer. So we got to start kind of with the all the English words that we did like on this one here, but this time when we write our answers, we can shorthand it because we don't actually need all the words. So here I'm going to say it's a reflection over the x-axis. There's my shorthand rx for it, and we're also going down 1 unit. Some students might have said, hey, isn't this a reflection over y? Because if it's over x, this guy up here, this dotted, now if I flip it down, it's down there, and that's x. But what if it's y? Because if it's going up here and I put it over there, that works as well. So it could have been x or y. It actually doesn't matter. So both in this problem would have been correct. So if we put a little y there, for this problem would have been fine. Turns out the next one as well, but it wouldn't have worked on the first 2 questions. So it's not like every problem. So do be on the lookout for that, but I'll grade correctly. I'll make sure that on the test both answers would be written as correct. Anyways, those from our notes from before, reflection over the x-axis is always the letter A, in this case -1, and down 1 means that D is equal to -1. So our final answer, plugging it into this format, there's no B and there's no C. Our correct answer here is g of x equals -1. You don't really need to write the -1 if you don't want to. X and then -1 on the outside. If you wrote the -1 in front, that's fine. And again, if you had said the letter B, put it in front of that, that's cool too. Let's go on to number 4. Same exact idea. This one's a little bit harder to see, but our concept here is we were pointing kind of like this before, but now it's been flipped down and moved 2 to the right. So we're going to call that again a reflection over the x-axis. And this time we move to the right by 2 units. This is again that letter A being a -1, but this time here we have a C being a -2. Be careful with that letter C, because letter C is the opposite of what you think. It moved 2 over to the right, and that made it negative. So our final answer here, we have g of x is equal to negative on the outside again, f of x minus 2. Let's keep the ball rolling. On to problem 5. So describe these transformations necessary. So we have so again, we're doing just like number 1, but now we have the function in front of us. So we have a negative in front of the x cubed. So that's our letter A again is -1, and we have that guy on the outside, that's our D on the far outside. No parentheses in the question, and because there's no parentheses, guaranteed there's no B's and C's. So we could say it is a reflect over the x-axis and shifted down 2 units. Cool stuff. All right, problem number 6. So moving on to problem number 6 here. This time we have our square root here, and everything is on the inside of the square root, which means that this guy right here is our b being a -1, and that guy right here is our c being a +1. So this time it's a reflect over the x-axis, or sorry, y-axis, reflect over the y-axis, and shifted left 1 unit. And again, don't forget that c does the opposite of what you think it does. So if you think it moves, +1, you think it moves right, but actually moves to the left. So be careful with that. We're already done with the first page. Let's keep the ball rolling here. All right, number 7. So this one tripped up a lot of students because it's the first time I've had a question quite like this. I won't do this on the test because I know it's a little bit more annoying, but just so you can see the answer, if it comes up in that college class, here we go for it. This guy out front is still that letter A being a -1, and this guy here, we know it's not a C or a D because it's not addition or subtraction. The only letter left is that it has to be the letter B. We have not had a fractional letter B up to this point, so we kind of don't know what to write for it. That's okay. The -1 is a reflection over the x-axis. But this guy right here being on the inside, letter B from our notes, what that means is this is a horizontal stretch or expansion. I like using the word stretch by 2. Why is it by 2 and why is it a stretch? So most people think a half would be smaller, but again, that B and the C do the opposite of what you think. So the fraction actually pulls it apart, and it's by 2 because it's 1 over whatever it is. So whatever this number is in the bottom is how much you're doing it by. It's kind of like you're dividing by 2, so it's by 2, kind of the concept there. I think the original value for B is a 1. Let's check out this other one here. So this guy, again, we have the A is actually both of them, right? We have A being a -1/2, and that does 2 things. It does the original reflection part, so reflection over the x-axis, but it also does, this time it's the letter A. So letter A acts the way you think it does, so a fraction does a compression. So it compresses vertically because it's that letter A is a vertical. So compresses vertically, compress vertical by 2 again. Easy peasy. Maybe not easy peasy, but who knows. All right, so number 9. So going through this, remember there are a lot of different methods to doing these questions. There's that number method, there's the visual method. I'm going to do the number method once, and then I'm going to do the visual method for the rest of them because the visual method is faster and I'm a little bit lazy. But I do want to show that number method just at least once. So the number method here for number 9, we want to remember that the original function is the absolute value function from our notes, and therefore our original table is x, f of x, and we have a -2 and a 2, a -1 and a 1, 0, 0, 1, 1, and 2, 2. There's our original table. And from this information here, we know that that letter C right there is going to be a -3, and this letter D right there is a +2. More from the notes, C always affects the x values, D always affects the y values. So if we are changing this guy into our x, g of x column, what we are doing is we're taking all of these values here and we are adding 3. Remember, it does the opposite of what you think, so be careful. So we're adding 3 there, and this one does exactly what you think. You're adding 2. So we're adding 3 to every single one of these. -2 plus 3 is 1. -1 plus 3 is 2, so on and so forth, 3, 4, and 5. And for the g of x, we're adding 2 of them, so we get 4, 3, 2, 3, and 4. And from here, we just want to go ahead and play, connect the dots. If you want to use a ruler or graph paper, you can feel fancy, but I am lazy. I am not doing that. We have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We got a 1, 4. We have a 2, 3. I'm going to pause really quick. My cat is being very loud. All right, so I don't know if you guys really hear my cat meowing like crazy, but it was very loud, even through the headphones. So feeling like you could hear it, but whatever. Anyways, where were we? We were graphing this guy. We had the 1 comma 4, we had the 2 comma 3, and now we need the 3 comma 2, and we also need the 4 comma 3 and the 5 comma 4. And just like we expect with our absolute value, it creates that nice little V. Beautiful. Wonderful, wonderful. All right, so there's our number method. Not too shabby, but I'm going to go ahead and do the visual method for these last three because that is, again, faster, and because it's faster for me, that's what I'm doing. All right, number 10. G of x is equal to a negative square root negative x. So our parent function here, or f of x, is going to be that square root of x. That guy here in front is that a is a negative 1. This guy right here is a b is a negative 1. So this guy reflects over the x, and this guy reflects over the y. So our original graph, looks something like this. And if we're reflecting over the x, like reflecting over x is going to do this. So it's going to kind of go down here. And then reflecting over the y for our final answer is going to be over there. So for our final answer on the graph, we kind of want it to look like this. Now on the test, I would probably give that full credit, but if you wanted to be more specific, you kind of like make this a little bit straighter. And I'm going to show you guys a trick in class on Monday and Tuesday about how you could do this with the calculator. So, yeah, anyways, there's that. Cool beans. So, number 11, g of x. We got that negative 1 over x plus 3. Same exact ideas here. We have that a being a negative 1. We got that c being a positive 3. So that's a reflect over x. That's going to be a moving us left 3 units. So our original graph, our f of x, is going to be that 1 over x, which looks something kind of like this. So to reflect it and flip it upside down, so we're taking this guy that was in the top right-hand corner and flipping down is going to be in the bottom left-hand corner, kind of like this. And then we need to move it 3 left. So just an idea, the easiest way to do this is kind of to make this line here, x equals negative 3. The concept is that dotted line is never going to get touched. So we're looking at like this because our original dotted line was kind of at 0, and then now the graph kind of looks like this. Gorgeous. All right, number 12. We have, again, fx is going to be x cubed, and our original graph kind of looks like that S-looking thing. And we got an a is a negative 1 in front. We have a c being a negative 2, so that's where we reflect over the x again. This is moving to the right 2 units. So what's this picture going to look like? Well, reflecting over the x is going to move it up and down, and then we're moving it to the right 2 units. So our s kind of begins there, but then it goes down here, and it goes up over here. Oh, that was kind of terrible, but again, I'd probably still give full credit for that. I'm not that strict in this. I just want to make sure you know how to get the general visual picture. Moving on, here we go, number 13. Identify that parent function and write an equation for the function given. So this case, we have to write the equation. That's going to be this one here. So our original parent function, f of x, is going to be our x cubed for this. It looks like our little s. And from there, we got to figure out what happened. So like our original s would have been like right here, kind of moving like this. And so the new s has been moved down 1, 2, 3, and then moved over by 1. So we've gone down 3 and to the right 1, which means that d is negative 3 and c is negative 1. Rewriting it in the correct format, we have g of x is equal to x minus 1 cubed minus 3. Keeping the ball rolling. By the way, if this is too fast for you, that you're not understanding what's going on, don't forget, you're always allowed to come to my tutoring hours, Monday and Wednesday after school. You can come in during lunch. Maybe you got a free period, you can come talk to me about it. I'm available for help if you need it. We got f of x is equal to the absolute value of x there, and we have a clear original problem kind of points up. This one's going to be reflection over that x-axis because now it's pointing down, and it's also going to be moved up 1 unit because the original graph is like right here, and the new one has been moved up by 1. So that's kind of a is negative 1 and d is positive 1. Using our knowledge, g of x is going to be equal to negative absolute value of x and then plus 1. Forget to box the last answer. Keeping the ball rolling. Number 15, let's do it. So, number 15, we got that square root looking function, kind of like a swoosh like that. Specifically, the old one would have went like this originally. So this one's to the right 2 and down 3. So we could say that our original function is f of x equals the square root of x. And we moved to the right by 2 and down by 3. That means c is negative 2. This means d is negative 3. And what's that mean for us? We got f of x is equal to the square root of x minus 2 and then minus 3 on the far outside. It is not under that square root. Make sure it's very clear to me the square root has stopped. Otherwise, I will not give full credit for an answer like that. All right, number 16. Flipped upside down, moved 1 again. It's almost identical, honestly, to problem number 14. So it's just that f of x is now the x squared, but we still have the same reflection over x, the same d, up by 1. So d is plus 1. So we have a is negative 1. So our final answer is g of x equals, we got a negative x plus 1 squared. Oop, I failed. G of x is negative x. We don't even need parentheses there. Plus 1. You don't even need parentheses. I don't know why I put parentheses. I'm going to write it one more time. I'm going to write it the correct way. This is how it should look. Okay, Mr. Richards. Get it together. Last page for this guy. Here we go. Number 17. Reflect across the x-axis, translate down 1 unit. We just have to write it. So it's the same exact thing as last problem, except now they give us the words, and we have to use those words to rewrite it. So we have g of x is equal to reflecting across the x-axis. That means a is negative 1. Translate down 1 unit. That means that d is negative 1. So we have negative x squared minus 1. The same answer as the last one. No, the last one was plus 1, right? Reflect across the x-axis. Again, a is negative 1. Down 2 units. D is negative 2. G of x is equal to negative x cubed minus 2. Right 2. C negative 2. Careful with that letter C. Translate up. D is positive 1. G of x is equal to, we got x minus 2 squared plus a 1. Beautiful. And now we got left 2, up 1. So left 2 units. That means right here that C is positive 2, up 1. D is positive 1. So G of x, we got x plus 2 squared plus 1. Gorgeous. Just gorgeous. I box all of them. I forgot to box all my answers. Okay. And we're done. Have a wonderful rest of your night, guys. Peace out. Have a great weekend, etc., etc. Peace out.